Hello, welcome back to my YouTube channel, Learn Physics Better with Blessing. I started a very interesting topic, which is motion. Please, in case you missed out or you did not watch the video, please go and watch it because it contains a lot of interesting points and key points about motion. Please go and watch it. So today I'm just going to continue on types of motion, which is a type of motion, and I'm going to be treating circular motion and rotational motion. Circular motion, I'll start with the definition. Circular motion is the movement of a body along a circular path. Circular motion is a movement of a body along a circular path. And in this type of motion, it's not all the body that are involved. It's not all parts of the body that are involved. Do you understand? Like, it's not all parts of the body that are involved. I'll take an example. An electric fan blade when working. A standing fan. Sorry, I can't bring it live. I'm going to use it. Please use your abstract knowledge now. When you plug your electric fan on, if you notice, it is only the blade that is moving, not the whole body. So that movement of the movement of the blade is in cycles, round and round, round and round in a circular path. So that blade is undergoing circular motion. It's only the blade that is undergoing circular motion, not the whole electric fan. I'll give another example, and this one is live here. The movements of a clock spindle. This is the spindle here. This red, if you notice, is going round. Don't look at the shape of this clock. Don't look at the shape of this clock. But if you notice, this spindle is going round. Don't look at the shape of the clock, but just look at the movement of the spindle. See, it's going round, round, round. A cycle. It's going round, cycles, 360 degrees round. Please don't look at the shape of this. Don't let this shape confuse you. The shape of the clock, don't let it confuse you. The movement of this spindle is undergoing a circular motion, and if you notice, it is only the spindle that is undergoing a motion, not the whole clock. It's not the whole clock that is moving. It is only the spindle that is moving. That is an example of circular motion. I know with the way I wrote it, you would think circular motion and rotational motion are the same. No, they are not the same. There's a slight difference. In rotational motion is also round, like it's also cycle, but in this type of motion, it is the whole body that is undergoing motion. It is the whole body that is undergoing the motion. I'll give an illustration. I have a live example here. Rotation of a kicked ball. I place this ball here, or let me stay here instead. I place this ball and I kicked it. You see, the ball is moving. Can you see, from one point to another? Let me kick it again. I can't really play ball though, so okay, let me kick it slowly so you get my view. I'm going to kick this ball now. Watch the movement. Hey, sorry. I'm going to kick this ball now, so you just watch the movement. Watch how the ball moves. Round and round. The ball is going to move round. Let me kick it. Can you see it? Round. From one point to another. From points here. From this point. Let me use my hand so you get what I'm saying. See, the body, the whole body of this board was moving. It was moving from one point to another. That is an example of rotational motion. That is an example of rotational motion. So let me do a recap of what I said. Circular motion is a movement of a body along a circular path. I gave an example, movement of a clock spindle. And In circular motion, it is not the whole body that is undergoing the motion. A part of the body is undergoing the motion. And I gave clock spindle. It is not the whole clock that is moving, but only the spindle that is moving. I gave another example, electric fan blade. In the electric fan blade, it is only the blade that is moving. The fan is still at its position. It is only the blade that is undergoing circular motion. Also in rotational motion, I said the whole body is moving from one point to another. I gave an example, a wheel of a bicycle is moving round one point to another. And also a kicked ball, which I displayed now, although it was a bit funny. A kicked ball, and that is all. So in circular motion and rotational motion, there's a slight difference. Please don't think they are the same. They are not the same. There's a slight difference. Circular motion, a part of the body is undergoing the motion. Rotational motion, the whole body is undergoing the motion. I'm going to continue with another type of motion, which is random motion. Random. From the name random, you know that it is disordered, like a disordered movement, like movement of a body in a disordered way. Or like, let's just use our local language, jaga jaga. Movement of a body in a jaga jaga manner, no direction, it's just moving. I'll give an example, movement of gas particles. Yes, movement of gas particles. I don't know. Okay, let's just use smoke, for example. Smoke. If, for example, something is burning, and if you look closely, the particles are just scattered. If you look closely, I know you say, are they not going up? But if you look closely, the particles are scattered. Particles of that smoke is scattered. Then gas, like we know now, gas undergo random motion. Another example, okay, let me just give a clear example now. Another example is movement of suspended particles in water. Like you put a glass of water, transparent to be precise, put a transparent bucket, fill it with water, and pour sand. Let me not disturb you with pouring grains. Just try pouring sand on it. Sprinkle it. You notice at first, before it will rest at the bottom, it will be scattered. Before they will finally rest at the bottom, when you sprinkle it, they will be scattered. They won't just jump and go down. They will all be scattered. So that's scattered way. That movement in scattered way is also an example of random motion. I'm going to continue with the third type of motion. Thank you for watching. Please don't forget to subscribe and turn on your notification button. You can also comment on questions that you want to ask, and also drop some suggestions that will make this video, that would have made this video better. Feel free to fill in your suggestion. Stay safe. Thank you for watching.